This is Andrew Lewis, and I'm your panel moderator here. And we've got some exciting guests to talk about their experience in digital twins in manufacturing. Let me see if I can. Charlie Sheridan from Google has dropped out. He got sick this morning and had turned in, so I'll be filling in another use case for him. But first I want to introduce Amit Digar. Is that how you pronounce it, Amit?
Yep.
All right. And his background, an exciting background here, he leads a team of global data scientists at Novelis, where his team builds complex, advanced analytical models leveraging sensor data from 2,000 plus sensors captured at milliseconds of granularity. That's a lot of data. A part of manufacturing, Amit has worked in various industries, including retail, CPG, digital marketing, and healthcare. He holds a BS in mechanical engineering and an MBA with a focus on computational finance from Cornell. In his spare time, he loves to play ping pong and build home IoT projects using Raspberry Pi. So Amit, this guy, you are hardcore. So let me go on to your slide here. All right, Amit, you want to take it from here?
Andrew, I can't see the slide yet.
All right.
I think I can get started. So within Novelis, basically, what we do is we make aluminum coils, and we make these coils from recycled aluminum. So one of the things about aluminum is infinitely recyclable element. So we buy the scrap, either the used beverage cans or automotive parts, and we melt them, then we cast them, and we roll them to make the slides. So one of the components of our process is this melting process, right? So we have these gigantic melters. Think of your home furnaces or home ovens and multiply that by 500 times. That's how big these ovens are. And we basically pour the different elements at different times, right? So we pour the used beverage cans first, aluminum scrap that we buy from automotive second. We put like hardeners, we put alloying elements, and it's kind of like we are making pizza inside the oven, right? So that's the process here. And what used to happen in the past is we had a thermodynamic model or equation basically that used to where people would input different parameters and it would predict how long a batch is going to take, right? Well, in reality, when you think about all these complex additions that are happening to the melters, you can't really predict or you can't really capture all those things at the start. So this thermodynamic equation that we had was fairly inaccurate, right? So the operators never really trusted it. And then they would sort of like always open the door of the furnace to check whether the batch is done, whether the aluminum is molten. So they would open the door, take a sample. And what would happen is whenever they open the door, a lot of the heat got lost, right? So it affected our fuel efficiency. And because of that frequent evaluation or checking, our throughput was sort of like, our batch was actually taking much longer than it should be, right? Because we're losing a lot of heat and there was this sort of like noise in the process of frequent opening, taking samples. So we decided to basically build data or build a machine learning model taking data from all these sensors to accurately predict when aluminum batch is done, when aluminum is molten. So what this model did is it basically took data from multiple sensors. So we have, I think we have 20 or 30 sensors within our melters that capture temperature at different points. We capture viscosity, we capture weight of the aluminum, we capture pressure in the melters. So using all those data elements and also keeping the thermodynamic equation as a base, we sort of like try to adjust or understand these situational factors, these additions that are happening in real time. And we built basically this machine learning model runs in real time and gives an alert to the operator when a batch is ready. So what it did is it sort of like freed the operators to focus on other works. They don't need to go and keep opening the furnace all the time. It affected our improved our fuel efficiency significantly. So now our batch basically, we don't lose any heat from the melters. And third is it actually improved our throughput. So this particular machine learning model using sensor data added millions of dollars of value on an annualized basis to our operations. So I wanted to sort of like talk about this one case study where we benefited by combining the IoT data and machine learning and made operational improvements.
This is really great. Did you use, I use a lot of thermodynamics the old-fashioned way. Did you use any of the thermodynamic calculations as part of any feature extraction?
Yeah.
Or any way to build your analytic model, your AI models, machine learning models?
Yeah, so the machine learning model basically sits on top of the thermodynamics. So we have the thermodynamic equation, which does the basic prediction, the prior of the model. And then we have a Bayesian model, which basically gets a posterior using all the signal data. So it's sort of like a combination of the old world and the new world. And that gives a benefit.
That's the power, of engineering, having engineering in with the data science. Can you comment on that?
It's actually, we are realizing that engineering, if you keep physics, thermodynamics, and engineering as a base for every machine learning model, you sort of like augment those historical rules-based things like physical laws and apply machine learning to explain the noise. That's when you basically get the best value from your machine learning operations. So we have deployed about 20 models right now, and the underlying base of these models is the physical thermodynamic or physics equation that goes on.
Well, that's some great work, Amit. Okay, we're going to move on. We can come back to this. Profin, you are up. Let me get my slide going here. So I'll read a little intro for Profin is, no, excuse me, John, you're up next.
Okay.
Sorry, they've changed the order here. So John, you are an engineer too. I guess we're all engineers here. Attended engineering school in the UK, had a 30-year career in semiconductors. In 2017, he decided to form his first software company working with co-founder Angie Stitcher, who had recently left Apple. That's quite a combination. Together, they have created Ursaleo, a company bringing photorealistic 3D digital twins and state-of-the-art user interface to the industrial market. Because now you live in San Francisco, and that's where you founded Ursaleo. So let me see if your slide is here in the right order. Okay, here's your slide.
All right. Yeah, thanks very much, Andrew. Yeah, so thanks for the intro. My name is John Burton. I'm based in San Francisco. We're focused very much on the visualization of IoT data. So traditional IoT systems typically use 2D dashboards, which work great. However, we founded a company that we were aiming to do a lot more with that information. So you can see here a screenshot of one of our models. This is the case study I'll talk about. So this is actually a gas compressor unit. These things live out in the field next to pumps on pump pads. And what they do is oil comes out of the ground, methane gas is dissolved in it. And as the pressure comes off the oil, the methane gas is released. That's why, if you can remember back in the day, you used to see these great big flares above oil wells, which is basically the methane gas being burnt off. This compressor unit's from one of our customers called Flogistix. They're based in Oklahoma City. And what this unit does is actually collect that methane gas in that big tower to the right. And then this unit takes that methane gas and compresses it to a suitable atmospheric pressure where it can be sold into the infrastructure and used as a natural gas source. So it's an additional source of revenue for the driller, and it also much more environmentally friendly, obviously, to be collecting this methane gas rather than just burning it off into the atmosphere. So the Flogistix came to us, and the major cost for them is maintenance. These things are in remote locations, so typically North Dakota, West Texas. And when they have to send a crew out to maintain them, it's an expensive proposition. very often they found when they sent a crew out that what they were maintaining was actually something pretty simple. So they asked us if there was a way that we could apply our technology to help with the maintenance process. And what we did is we provide these photorealistic digital twins. This is actually an FX17, one of their compressor units. And you can see it's got a lot of drawing on the screen. This would be a collaboration session between the on-site user of the compressor and the Flogistix team back in either Denver or in Oklahoma City. So the idea is when something is the IoT readings are throwing an anomaly, rather than just calling out a truck roll from Flogistix, the first stage now is the customer can actually initiate a collaboration session right in the 3D model. Use advanced visualizations to see things like fluid flow, fluid levels through the model, and using that data, collaborate with the team from Flogistix to see if they can fix it without bringing them out on site effectively. And initial feedback is they're going to save around 10 to 15% of their maintenance costs through this approach, because they're just going to cut down the number of truck rolls out into the field by that much. And for these guys, that's a very significant amount of money. They spend something around $30 million a year on maintenance. So a 10 to 15% reduction is significant. So this is typical of what we do with the 3D models. It's taking the IoT sensor data, applying it in unique and unusual ways, combined with 3D technology to provide things like enhanced maintenance.
I would imagine that, John, this would be a big help in the change management, getting boots on the ground out in the field to adopt this scary concept of, everyone talks about the perceptions, the robots are coming in, they're going to take over. Yep. This is actually enabling humans to be smarter. Can you comment on that?
Yeah, so one of our goals, I mean, I think you mentioned in your intros, Angie's from Apple. Most of the rest of the team are actually game designers, or a good chunk of them are game designers. There's an obsession with the company with user interface and making the technology get out of the way. To your point, people who don't use technology on a daily basis, if you bring in technology and it's a learning curve and it's difficult, they will find every excuse they can, every way they can not to use it and continue using their old methodologies. If you can make the technology so good from a user interface that it just gets out the way it was when you turned on your iPhone for the first time, you just used it. That's kind of our goal is to make this technology so painless that people just use it and don't even really notice it.
What about creating these models? What you have here is beautiful. And by the way, I'd encourage the audience to go check out the Ursaleo website. This little 2D image does not do it justice, what's there. And even on the homepage, you can see the vibrancy, the interactivity. And my experience is the more interactive and visual data is, the bigger impact it has, especially on leadership who are cutting the checks for these projects, by the way. But so what kind of data do you need for these models? This is pretty complex.
Yeah, so CAD files are ideal. We've kind of automated the process. So this is using a Unity gaming engine. So everything you're seeing here is displayed using gaming technology. The reason we use that is it works on everything. It works on an iPad, it works on an iPhone, it works in virtual reality, works in augmented reality. It also provides you lovely lighting, stuff like that. So to create them, usually start with CAD. We've got that process down about 97% automated. We think we can make it 100. If you haven't got CAD, then yeah, there's other techniques we have to use like LiDAR scanning or photogrammetry to start off. But we've done this enough now that we can make it pretty painless.
Well, this is really cool. I can see one day you can put a pair of eyes on a project that a young engineer could go out there, but you could have a senior level person, one of us old guys out back in the bunker, really looking at what's going on. And you don't necessarily, I guess you don't even need the eyes on with this because it's all digital. This is pretty amazing. Okay, well, I'm going to go on to our third panelist. This is Pravin Kirana from Nexteer Automotive. He's a staff manufacturing engineer at Nexteer in the advanced manufacturing engineering department. In this position, Pravin is responsible for leading teams for the development and and implementation of predictive analytics technology to support digital manufacturing, including deployment of real-time IIoT-based process monitoring systems. Pravin has earned a BS and MS in mechanical, yay, another engineer, and a PhD in industrial systems engineering, and was recently honored with the Frost & Sullivan's Manufacturing Leadership Award. Pravin, you didn't put on here, what school did you do all this great work at?
My bachelor's is from Kettering, which is in Flint, Michigan. Master's is from University of Michigan, which is in Ann Arbor, and PhD is from Oakland University, which is in Rochester Hills, Michigan. So all from Michigan.
That's awesome. Well, you are, like I said, another engineer. Engineers rule, you know, and especially in the manufacturing space.
That's right.
I think that's what makes a successful project, is that cross-functionality between engineering and data science. And then you got the computer science folks on there as well. Let's see if I can get to your slide here. Here we go. This is your slide, correct? Yep.
Yes. So,
all right, have at it.
Okay, thanks for the introduction, Andrew. So as Andrew said, my name is Praveen. I work at Nexteer, and I'm based in Saginaw, Michigan. So at Nexteer, we produce high volume steering gears, driveline, and columns for various OEM manufacturers. So the objective of this particular case study that I'll be discussing was to reduce reject rate for our end-of-line function test for steering assembly. So the steering assemblies are 100% function tested for many, many functions. Hundreds of functions are tested, and failure for any of those functions is expensive, because if a steering assembly fails for even one function, it has to be torn apart and the faulty component has to be found and replaced. And then all the other components have to be built back in. So it's very, very expensive to have failures at the 100% end-of-line function test. So past approach to identify what are the factors, what are the components that are causing these failures has been either swap studies or has been control studies. So I remember about 10 years ago when I was working on my Six Sigma Black Belt project, we're looking at high reject rates for end of line for a steering gear. And we were interested to see if the rack, the induction hardening process for the rack could be the factor. And there was 4 spindles for that rack induction hardening. So I had the operator paint each spindle a different color. And then I had the operator at the end of the line that was, when they had a reject, I would have them take the rack out and then keep track of what color was failing the most often to figure out which hardener was causing, which station was causing the issue. Fast forward 10 years, now we have a lot of rich data that we can use for machine learning and help to solve problems much faster, more effectively. So the solution, the part one of the solution has been using machine learning technology to identify features and factors that influence the end-of-line function testing. So I'm using our production data from our digital trace manufacturing, which is an initiative we started about 6 years ago to connect all the components, subassemblies, end-of-line function test, component all the data from all these different individual machines into a single pipeline, into a single data. So right now we have over 5,000 machines globally that we have connected to this database. And now that we have this rich data, I can use it to more effectively solve problems to reduce the end-of-line reject rate. So I used machine learning to discover factors that were previously not known to influence reject rate. For example, the team found out that the weight of one of the components had a significant effect on the function test performance. And then we worked with our supplier to shift the target weight for this component, which reduced our reject rate. Part 2 of this case study was to install real-time vibration monitoring sensors on the critical machine manufacturing processes. So this allows us to catch the faulty components at the component processing instead of at the assembly level. So for example, if it's $1 of scrap at the component level, it might be $5 or $10 because you have all the additional disassembly and so on involved if you catch the problem at the assembly level. So the solution involved having edge computers connected to vibration force sensors on these critical machines that monitor each cycle and detect anomalies in the vibration and force data and stop the machine if there are issues. The data is also sent to the cloud where we have real-time dashboards that support root cause analysis, and that's based on the frequency spectrum analysis. If a certain part, or there's a frequency at 300 hertz, we can relate that back to, let's say, an inner race or outer race defect frequency of a spindle. So based on the vibration data, we can detect or identify what the issues are, as well as trends in machine degradation. So the benefits of this case study.
Praveen, let me interrupt you here. I think we have limited time, but I want to ask you a question. I think it's very important. What you just talked about, you bring the data. First, this is a true edge solution on a machine. You're using a LabVIEW environment to do all your computational work. And then you're sending the work back up into the cloud and providing your users a set of diagnostics, which you were just talking about, in terms of the vibe tech involved.
Exactly.
What is the impact of those diagnostics on on engaging your technical staff to use this platform?
Yeah, I think that is one of the main technical benefits of this project. In fact, right now, we have these systems set up. We're deploying these systems in Saginaw, Mexico. Right now, I'm working with some engineers in Mexico to help them troubleshoot some issues with the machines in Mexico. Again, looking at the spectrum analysis of the vibration signatures. So I think having this data available so that our experts can look at the data, whether the machine might be in Mexico or in China, but we could have experts globally look at the data and provide feedback of what the issues are.
Yeah, that is really important. And folks, my experience is that there's always a skepticism about this AI generically, machine learning, deep learning, NLP and everything. But when you can show them the results in the context of what they know and what we as engineers know, you're going to get so much more buy-in, user acceptance. It really becomes a very, very valuable tool. So let me move on to the next panelist, me, yours truly, and let me get to my description here. So I'm an engineer, a technology executive, a visionary with direct experience managing startups and even manufacturing operations. I started my career on the F-16 program. I'm a CEO now of Decision IQ. It's a Georgia Tech startup back in 2015. We're a technology integrator for AI. We do both, we have a lot of experience. We bring that experience to help clients with their projects. We also provide technology services. 6 years doing this. We're also an Amazon technology partner on the AWS platform. We've helped our clients achieve over 16 million in operational savings, including Georgia Pacific. That's the use case I'll show you, Coca-Cola, and Cox Communications. So our expertise includes predictive maintenance, predictive quality, and yield failures on the process side, supply chain as well. So I have a BS in aerospace engineering and from Georgia Tech and an MBA from University of Chicago. So the use case I wanted to discuss with you is the Georgia Pacific. We are actually monitoring 2 wood mills for OSB board. We onboard the entire plant, both vibration sensors and PLC data. And we were in a real-time monitoring. Georgia Pacific pushed the sensor data up to their cloud account, and we installed our platform that we built for them, really their platform, into the cloud for them. And we were doing something very similar to what Praveen was talking about, is that we were monitoring the results, creating failure alerts, and then pushing that data back to the engineering technical staff. We didn't start out doing it that way. We really presented them the data science models and everything, and it really created a lot of confusion. And we didn't show the underlying, what I call diagnostics. And when we swapped that and led with what they were always used to seeing, it had a huge impact on the adoption. So we basically improved and provided savings of 4% of availability to the site. So 4 points out of 100 is very significant savings, about 4.5 million per site in increased availability. We had an average failure warning time of 30 days. These were not prognostics-based failure detections or anomaly detections. We have done and are capable of doing prognostics-based work. This was basically an alert to a failure underway. ROI on the project was about 22x. And so basically the data was key factor is that as these companies add more and more sensors, this creates more demand on their vibe techs and other maintenance technicians to look at the results. So the key is to improve scalability by presenting them the alerts of where failures are occurring them and allowing them to ignore the alerts or the concerns that the false alerts is the real key. So we're a big believer in human in the loop to use these diagnostics that Praveen and others use to help them vet out the alert, to distinguish between those. Praveen, did you ever deal with any false positives in your deployment?
Yeah, I think that is a technical challenge to be able to understand what are the false positives and minimize those.
Yeah, not only, and by presenting the diagnostics to the technical team, they can do it. And then, so we were able to show that one engineer, a mechanical engineer, could support 5 sites at about 250 sensors each. And so it provided tremendous scalability because many companies are looking at going not just from 200 sensors per site, but up to 1,000 plus sensors per site. And so if you're presenting a 40% false positive rate, 30% false positive rate, that will have an inverse effect of actually creating more work for the technicians on the floor to go out and inspect. And the biggest fear that every technician has is what have I missed? What am I not finding on my walkarounds? And so you have to build a system that builds confidence that they're not going to get caught overlooking something. And that's the key, is marrying the vibe tech, the PLC data with the underlying diagnostics so that they can be assess each alert that comes through.
Yeah, so Andrew, to add to what you just said, I think
yes, sir.
Sort of like balance between precision and recall, right? Like false positives and false negatives is a pretty difficult one in many cases. How do you weigh those, right? In some cases, you don't want to create more work for people, but at the same time, you don't want to miss on things that could have been good indicators of failure, potential failure. So it's always a very difficult balance for us as well. And there is no solution for that. It's like largely you have to pretty much work on a case-by-case basis.
Yeah, I would suggest that what's becoming the hard, as we all mature in our ability to do this, it's the change management is becoming more and more the challenge of how you integrate AI into a workflow.
Absolutely, absolutely.
Can anyone cite any examples of? Well, I cited one example where. Well, I heard one story from another client that an earlier vintage of technology, it wasn't ours. The technicians put the iPads in the microwave. They just didn't want to have anything to do with it. There's a lot, and of course, everyone fears the robots coming. But does anyone have any stories they can share with change management, either what they've experienced or what they see as how to foster adoption of AI in a manufacturing environment?
Yeah, I can probably start and give you a few examples that actually, I mean, change management, as you mentioned, is a very big component for us to get any adoption with our AI initiatives that we are doing within the company. And it has been a pretty rough journey, I would say. We have started about 2.5 years ago. So it's sort of like started, well, we don't want to do anything with that, to now, okay, at least we'll look at it. If you give us a solution, to in some cases, now we'll start using it, right? One thing that helped us quite a bit is actually if you make the thing more meaningful to them. So what we are doing in addition to this sort of like developing models is we are also helping our process engineers who are like really smart people, have a lot of process knowledge. We are actually upskilling them on this area. So they are sort of now learning AI. We have built our own machine learning platform, which is very easy to use to build models. So they don't need to understand all the nitty-gritties of those, but they can pretty much start and get the intuition. So that has helped us to get adoption. Now these people are sort of like building their own models. And now when they build their own models and when their colleagues adopt them, they sort of like feel that, okay, this is not any different than what we used to do in the Black Belt Six Sigma days, and that sort of like is helping us to push the envelope a little bit.
Okay, does anyone else want to comment on change management? I got a lot of cool questions coming through here from our audience.
Yeah, I was going to say I have
you go first, Pravin. I've got a good one.
Okay, I was going to say I have 2 lessons learned that I want to share. One of them is for the projects that I'm leading, to get the user adoption up front. I have a users group that I start right at the beginning of the project, and it's a monthly users group. So there's 2 or 3 projects I'm leading, and each project I have a users group that meets on a monthly basis, and that's a cross-functional team, including the quality engineers and the plants, the IT people, the product engineering groups. So having that team engaged at the beginning of the project is very critical, so that when the project is ready to deploy, they are part of the ownership. The entire team is part of the ownership, as opposed to thinking that someone is trying to push a system.
Yeah, that's very key. John, do you have anything you can comment on this?
Yes, a good one for us is another thing we can do on the 3D models is track moving objects, and that could be moving equipment, moving people. So we're rolling that out actually in the construction industry right now. So if you can imagine a construction site, being able to track workers, have they tripped, stumbled, fallen, been impacted by an object, that's all, great stuff. Health and safety is a huge concern. Almost immediately we ran into the unions, which was an amazement to me in 2021. So right now we're actually spending a lot of time meeting with the carpenters union, explaining that this is a benefit to their members because it's going to help them with their, track their safety. And I think with their buy-in, they will then say, okay, this is a requirement, and push it out to lots of construction sites almost overnight. But it is interesting that this technology is fantastic, but you've got to get the buy-in of the people who are doing the work, otherwise it ain't going to happen.
Where do you see the VR going, a rate of adoption of this? And I mean, I would think that the cool factor of this would make adoption very easy, or people would really get into seeing their equipment in a 3D world. Let me ask a question. Do you see a difference between older generation and younger generation in terms of the acceptance?
I don't think it's that so much. I think the cool factor is definitely there. I think VR especially has the real wow factor, but you can't wear a VR headset on a drill pad, and you can't wear a VR headset for 6 hours a day. So VR is great for training sessions and showing people how things work. AR, I think, is where the AR is the stuff that's going to get integrated into the day-to-day workflow.
Explain the difference, because to me, I'm a little distant from this. They're kind of the same. It's kind of
okay,
like
so VR is you put on a HoloLens, Oculus, and it blocks all of your vision except the 3D world. AR, you put on a Microsoft HoloLens, where you can still see the real world, but you've got these 3D images superimposed on it.
Okay.
So with a HoloLens, Microsoft HoloLens, you put it on, your hands are free, you can see the world, you're working on a piece of equipment, but all sorts of information is now floating in your vision on top of the real world equipment. So a lot of additional information is now provided to you.
What are some of the first questions you get from a potential client? Are you going to adopt your platform? Setup
cost. How much does this all cost to get going? Which is actually surprisingly moderate. The gaming engine technology is so good these days that for $10,000 we can get models up and running. And then how do I justify the business case? That's the other big one. Is okay, I love it. I've got to go to management and say why this is a good idea, and they want to see hard numbers, and that's why we focus very much on maintenance as the first application, because maintenance, hey, we cut this number on your spreadsheet 20%, will management like that? And it's a very, very quantifiable benefit.
Okay, I have a question here from Naresh. I don't know if I pronounced your name correctly. Excuse me for saying so, Naresh. But he asked the question near and dear to my heart. This might be a good one for Amit, but Pravin too. The confusion matrix. You guys are familiar with that. That's the relationship between false positive, estimated false positive, and true. Amit, why don't you explain the confusion matrix? You're the data scientist.
Well, the confusion matrix is basically a 2x2 matrix between true on the actual ones and the predicted ones, and you have the true positives and true negatives and false positives and false negatives, and you
Okay.
try to get the combinations of those.
Yeah. So so the question is, given that great explanation, are you gentlemen using the confusion matrix to produce better results? Or maybe I might suggest the question is, how do you use the confusion matrix? Because my experience working with data scientists, and I'm not one, was there was a lot of frustration when we were trying to produce solutions for the client, and they were moving data around in that confusion matrix, but never telling me that was their bounding box, that they had to deal with this reality, and there was so much variability and concerns about overfitting and everything, that it was a world that they didn't really, that the non-data science people really know about. And yet you guys live and die by that, don't you?
I mean, I do. Yeah, I think it's and that's again another thing that maybe is a little different in the engineering domain as compared to, say, some of the other verticals that I worked in. In engineering, actually, a lot of the problems basically are more regression problems. You're trying to predict something on a continuous basis, not largely as class, good versus bad. So a lot of people are not used to the classification approaches that people have. But that being said, I think I mentioned about this one of the sort of like derivatives of confusion matrix is this trade-off between precision and recall. Do you want to maximize your false or maximize your true positives, or do you want to minimize your false positives, right? How do you basically find that trade-off? And it's a very difficult problem, and I think you can't really have a single shot approach to that. You have to go case by case on that.
Yeah, I just warn everybody that if you're not a data scientist, to really understand your data science team is thinking in this context, and they're pushing the cluster around in this 2x2 quadrant. And you may not be happy with the rate of false positives, but then you might increase false negatives trying to reduce false positives, for example. And you're kind of really only as good as the data. But then we get into some of the feature extraction on the thermodynamics that can help tighten clusters up and things. Mm-hmm. So I have a question here for, let's see, Amit, you get a lot of questions here. So Praveen, can you add anything onto this issue of how you manage the data science in context of producing a usable result, in the context of balancing this world? Because that's fundamental to the data science, is this relationship between positives and negatives, what's predicted and what's actual.
Yeah, I think as Amit was saying, there's different methods to validate your results. One of them is a confusion matrix that applies to a classification problem where your output is a class, for example, pass, fail. For most of my applications where I'm working on the end of line function test, the output, it is a pass fail, but we also have a number. For example, there's a back drive friction. And let's say the limit of the back drive friction is 300 newtons. And if you have a failure at 302 newtons, that's a failure. But you could also have a failure at 500 newtons. So if we classify both those as failures, I lose a lot of my model. So I don't prefer to use classification for these type of problems. I use numerical output, which would be a regression type of problem. And for regression, I typically use R squared for looking at how valid the model is. The one other thing I was going to point out is a lot of the projects I'm working on, the focus is not necessarily to have a model with an R square of 0.5. In our case, a 0.5 would be very good because we have so much factors and variables. But my focus is, even if I have a model that has R squared of 0.2, what I'm looking at is what are the top 20 factors, features that influence my output, and that helps me then go back and look at, for example, the example I mentioned was we discovered that there was a weight of one of the components that had a significant effect on the end of line function test. once we discovered it and verified it with a control study, then we went back to our supplier to shift the target of that component. So it really depends on what the focus of your project is.
I think everyone listening to this, me included, you see how fungible these solutions are. This isn't a step function like putting a new PLC controller board on a machine. AI is not OT, or AI is not IT rather, excuse me, and that the IT generally gives a step function of capability. It's very predictable what the result's going to be. AI takes a long time to really produce a result, and it's really as much art as it is science. Mm-hmm. This can really erode morale over the time, because if they have the wrong expectations, or can leadership can start getting losing confidence in the project. Has anyone experienced breakdowns in support for their projects, given the time it takes to really build a good workable solution?
Yeah, it definitely happens. I think these things are really complicated, and you're not going to see immediate overnight results. And very often the management we're working with aren't technical, because they're from the industrial industry. They grew up as mechanical engineers, or that's their background, so they don't necessarily understand the technology. So there's definitely a sales piece to this, where you've got to over communicate, and you've got to read the room, read the emotions of the management you're working with. Definitely. Yeah,
there's a term I've heard called AI fluency. What is the fluency of your leadership? Is that important? Amit or Praveen?
I would say I think it is very important. One thing that Novelis did really well is actually all the manager, everyone until our CDO actually went through this data translator bootcamp, where they tried to understand this field of AI, how things are built, what is the probabilistic nature of the models that we build. So they understand now the kind of like the difference between traditional IT and AI, and that mindset is really helping us to sort of like push for the adoption of this technology.
Hey, okay, I got to change the topic a little bit. John, you're typing an answer. Why don't you give it to us? This is from Tom. Can you do anything else other than visualize what's happening, like analytics?
Yeah, so we connect to analytics platforms. We don't do analytics ourselves. That tends to be very vertical market focused. So to do good analytics, you kind of need to understand the data that's coming in. We're a piece of the solution, not the entire solution. So we do connect out to things like that. But I think he was asking the value around visualizations, or value around 3D models. So it's faster triaging of problems, remote maintenance, remote collaboration, which definitely saves time and money. It's reporting things on the 3D model. So instead of generating a paper report, you can generate a video effectively. Tracking people and things, which leads into things like time and motion studies. So if you imagine you track people and equipment moving around inside a factory over time, and then map all of that as a heat map onto a 3D model, that gives you a pretty good time and motion of what's going on inside the factory. So there's lots of benefits. It's probably a conversation I could talk for hours. I probably connect with Thomas offline and give him a full rundown.
Yeah, so Declan has a question up your alley there, John. How easy is it to create AR content? For example, a holographic 3D image of a machine. Is there a library of AR content available, or do I have to use for HoloLens?
Mm-hmm. So we're right in the middle. So we have a lot of visualizations already. So we've got a library of visualizations, translucent, make the piece of machinery go translucent so you can see inside it, fluid level, fluid flow, 3-dimensional heat maps, exploded views where you can imagine a piece of machinery sort of comes apart like an IKEA furniture drawing. So that they're already in our library. Targeting them to the HoloLens is something it's going to take us a little while. That's something we're in the process of doing now. We'll have it on an iPad very soon. So you'll be able to hold up an iPad and see all those visualizations. AR is relatively straightforward. VR is a bit more complex because you've got multiple stereographic images to deal with. It's the nice side effect of using the Unity gaming engine is these things are all built into the gaming engine as platforms to target. So once we've developed the visualizations, it's fairly easy to make them available.
Okay, time for another question or two. If somebody wants to push it through the Q&A section here, and then I'll wrap the session up. I do have a question. Any guys want to comment on where you think this world's going to be in 3 years, where we're not really looking at some quantum jump forward, but where is the advances going to be? Any comments?
I think in my world, 3D is going to become ubiquitous, and I think augmented reality is really going to become part of the workflow. It brings so many advantages. And I think that technology is just now sort of hitting useful status. Microsoft HoloLens 1 was not very well received. HoloLens 2 is a lot better. Apple's going to have augmented reality glasses coming out probably in 2021 or 2022. So that technology stuttered a bit with Google glasses, but now it's really starting to hit the mainstream. Virtual reality is well established as a training tool already. That's only going to get better. So I think, from my point of view, IoT and the merging of sort of 3D technology and augmented reality technology and wearable technology, all of those things are really hitting useful status now. And I think in 3 years, they're going to be widely adopted. Okay,
that's cool. Here's a question for Amit. How confident, this is from a person named Anonymous. Excuse me. How confident are you with the model you built for aluminum melting? I'm not sure how critical is your application, but the model accuracy is very important when it comes to data-driven modeling. Do you track that?
Yes, I mean, we do track the model accuracy. We do track the business impact, right? I mean, in our case, we had a baseline. So baseline was what was the process before, how long it used to take to melt the batch, melt the aluminum, and did we cut down that process? Did we cut down the cycle time? And as long as our models actually are cutting down that cycle time, as long as they're helping us improve the throughput, I think that's the value we track. And so accuracy, I would say, is not very important, because I think what we are trying to do is kind of like reset the batch, reset the baseline. So we had the human baseline. Now every month we sort of like try to create a new baseline and try to do better than that. So our goal is to start sort of like keep pushing that overall cycle time to smaller and smaller level.
Okay.
So
here's another question, excuse me for interrupting, from Ralph Rio. The case studies provided use a relatively small data set and not big data. Is this a correct impression? Well, I guess that's kind of, everything's relative. In the case of our work that we've done onboarding entire plants, we're dealing with terabytes of data. A key point that we do to offset this is reduce sample rates. We found that in terms of looking at a degradation of process or equipment, that you don't need real-time sampling, even though the source data for a site would be in the terabytes. So data in of itself isn't inherently mission critical if you over-describe something. Mm-hmm. Praveen, do you have any comments on that?
Yeah, I think I was going to say having a strategy at the edge computer is very critical to minimize your data size. So for example, vibration data. Vibration data typically is collected at 50,000 points per second. And if you have 10 sensors collecting 50,000 points per second, that's 500,000 points per second. And if you take all of that data, the raw data, send it to your cloud within a couple months with hundreds of machines, that's going to be terabytes of data. So the strategy there is to process the vibration data at the edge, extract features which are meaningful. For example, you can have RMS values, you can have spectrum data, which is a FFT analysis, and then you can look at, for example, if you look at the inner race defect frequency, you can identify that there are certain frequency bands, and you can figure out the energy in those frequency bands. So by doing that post-processing, then you can extract features and data from that vibration data and only send those relevant features to the cloud, not the entire raw data.
Yeah, and a key point, by the way, Praveen, you just talked about something that I brought up with Amit, that you're doing feature extraction using engineering, fundamental, classic, physics-based engineering to pull features out of the data and then building your models on that result. That's the big value added for us as engineers in the space. But also, if you look at a process that if you're dealing with a set of bearings that are going to degrade over 30, 60, 90 days, why do you need to sample at the millisecond range? You're really overkilling the solution. So the art of these great implementations is the simplification to knowing what is important and most of what's not important. and that really reduces the load on internal systems, edge computing requirements, cloud requirements, and there's compute costs, storage costs associated with all of that. Does anybody have, we have a few minutes left, and then I'm going to close it out. Does anyone have anything else they want to add here on our panel?
One thing I would say, Andrew, I think you asked a question of like, where do you see things going, the IoT things. I think one thing, at least in my world, what we are seeing is the computing is actually moving from cloud to the edge. So all the things that I think Praveen talked about, hey, we extract the features on the edge and then we push those to the cloud. I think slowly what's happening is a movement is happening where the actual machine learning models will also run on the edge. There's this new field of AI coming called tiny ML, where you're actually able to deploy like TensorFlow models and PyTorch models directly on the microprocessors and do the computation there itself. So that's sort of like one thing I'm seeing right now.
How do you update your models with tiny ML? How do you get back and rebuild those models on an edge case? Or edge-based solution, I should say.
Yeah, I mean, it's a very new field, right? It's still a lot of things are being kind of like changing as we talk. But I think the update is basically you're taking your say TensorFlow model you built in the cloud, convert that into a light model. So TensorFlow has released this TensorFlow Lite, which actually really cuts down the number of neurons and the number of layers and just keeps only the essential thing. And then you basically deploy that model as a JavaScript or as a pickle file, or H5 file on the microprocessor itself. So there is still a lot of advancements going to happen in the next few years, but the movement has already started.
Well, John, I would think your solutions could be very byte heavy doing visualization, but I'm sure you've got to, how is it require big pipes to visualize all this data in real time?
So we don't actually move a lot of data around. Once the models are set up, the live sensor readings coming in is pretty bandwidth light. The models themselves, an entire factory we did the other day was a couple of 100 megabytes because we compress it down a lot. We start with CAD, but we get rid of a lot of information when we turn the CAD into the gaming engine. If you think of computer games you play, you may not play them, but ones your son plays or your daughter plays. Great big 3D worlds can run happily on iPads or portable devices. Gaming technology is really, really efficient. So the initial model loading, that's a fairly, that's bandwidth intensive, takes up a fair amount of compute bandwidth. Once it's loaded, actually, we're not moving huge amounts of data around. The collaboration moves, compressed video around, but that can be easily be done over a cellular connection.
Okay, let me take you through some, wrap this, got some exciting announcements. So there are future events for the IoT world. On June 16th is the Smart Cities Day. August 12th, World Energy Day. October 6th, ICS Cybersecurity Day. And December 8th, we're back to World Manufacturing Day. So we appreciate your time. I want to thank our sponsors, Aliantia, Canvas, Eurotech, Hitachi, Vantara, Hive, MQ, Fortinet, Losant, Trend Micro, John Burton here, Ursulio. Thank you very much. Vertex and Well Aware. And so I really want to thank our speakers. You guys have done an awesome job. I've met with each of you individually. These are smart guys and very impressed. I've learned a lot from them. And I want to thank our attendees for the great questions. There's some also good questions here on the Q&A sessions. So we're going to move into the next session coming up. Lucien, can you advance the slide on this? This is what OEMs can learn from the Verizon's IoT product strategy. And it's online. This is a cool strategy. There's a whole afternoon full of sessions. And we really appreciate you coming to hear us talk and appreciate the great questions. There's opportunity. I did not address any of the questions that might have been posted on Twitter. So, but if you post them here in the Q&A section, we can answer them. I think you guys, our panelists, can look at the questions and type in an answer as well. Really, really appreciate the opportunity to, Lucien, to be a panel host, and appreciate the opportunity to present our use cases, and this is an exciting space. Lushin, do you have anything you want to close out with?
I just want to say thank to everybody that attended. Thank you, the sponsors, and see you in the next session. We also want to invite you for a networking session at 6 p.m. in the clubhouse. If you don't have any invites, feel free to reach out, or there are on the agenda for that session. There are ways to get an invite to the clubhouse. There are 3 rooms there: Industry 4.0, Industrial IoT, as well as Women in Manufacturing. So feel free to join us there. And it's kind of like the water cooler effect of a face-to-face. That's as best as we can do virtual. If you have any other suggestions, feel free to reach out. Thank you all.
Thank you.
Thank you.
Thank you.
Thanks.